Imagine for a moment that you are holding a regular coin in your hand. You toss it into the air, and while it is spinning, you know for a fact that it is either heads or tails. You just haven't seen it yet. That is how our world works. That is common sense. But now, take that coin and shrink it down 1,000,000,000,000 times until it is the size of a single atom. In this tiny realm, the coin isn't heads or tails while it's spinning. It is actually both, and it's not just both at the same time. It's also neither. But here is where it gets truly haunting. The moment you look at that coin to see what it is, the entire universe has to make a decision. And according to a growing number of the world's most brilliant physicists, that decision might actually be influenced by a future that hasn't happened yet. We are talking about a quantum paradox so bizarre, so fundamentally wrong according to everything we think we know about time, that it has left scientists questioning if reality itself is just a very convincing illusion. Today we are diving into the heart of the Wheeler delayed choice experiment and the terrifying possibility that the present is being written by the future. To understand why this scares people who spend their lives studying the stars and the building blocks of matter, we first have to talk about the famous double-slit experiment. This is the bedrock of quantum mechanics. Scientists found that if you fire tiny particles like electrons or photons through two slits in a barrier, they don't behave like little bullets. Instead of making two piles on the back wall, they create an interference pattern, like ripples in a pond crossing over each other. This means these particles are behaving like waves. They are spread out. They are in a state of superposition, meaning they are traveling through both slits at the exact same time. But the second a scientist places a detector at the slits to peek and see which hole the particle actually goes through, the wave disappears. The particle suddenly starts behaving like a solid little ball and only goes through one slit. It's as if the particle knows it is being watched. It's as if the act of observation forces the universe to stop being a blur of possibilities and start being a single, definite reality. This alone is weird enough to keep you up at night. But back in the late 1970s, a physicist named John Archibald Wheeler decided to push this weirdness to its absolute breaking point. He asked a question that seemed impossible. If the act of looking at a particle changes its behavior, when exactly does that change happen? What if we wait? What if we let the particle pass through the slits as a wave, and then only at the very last microsecond before it hits the back wall, we decide whether or not to measure it? According to our understanding of time, the particle has already passed the slits. It has already made its choice. It's either a wave that went through both, or a particle that went through one. You can't change the past, right? Well, in the quantum world, the answer is a resounding and terrifying maybe. When scientists finally performed this experiment using high-tech lasers and mirrors, the results were bone-chilling. If they chose to measure the path of the photon at the very last moment, the photon behaved like a particle for its entire journey, even the part that happened before the measurement was chosen. It's as if the photon looked into the future, saw that a measurement was coming, and changed its past behavior to match. This is called retrocausality. It suggests that an event in the future is causing an effect in the past. If you're a fan of space and the vastness of the cosmos, your mind should be spinning right now. Because this isn't just about tiny particles in a lab. Wheeler realized that this logic applies to the entire universe. Imagine a quasar, a massive glowing core of a galaxy, located billions of light-years away from Earth. This quasar emits a single photon of light. Between us and that quasar sits a massive galaxy. Because of Einstein's theory of general relativity, the gravity of that galaxy acts like a giant lens, bending the light from the quasar around it. The photon can take the left path or the right path to get to Earth. For billions of years, that photon has been traveling through the void of space. It passed that galaxy eons before humans even existed. But today, right now, you set up a telescope and a detector. If you choose to measure which path the light took, the photon behaves as if it took only one path billions of years ago. If you choose not to measure it, it behaves as if it took both paths as a wave. Your choice in the present moment is determining the history of a particle that began its journey at the dawn of time. You are in a very real sense reaching back billions of years and writing the past. This brings us to a terrifying realization. If the future can influence the past, then the linear flow of time that we rely on to make sense of our lives might be a total fabrication. Scientists are scared because this undermines the very foundation of cause and effect. In physics, we believe that A causes B, but quantum mechanics suggests that B might be part of the reason A happened in the first place. This leads us to the idea of the block universe. This is a theory in space science and physics that suggests time doesn't flow at all. Instead, every moment of the past, present, and future exists simultaneously in a giant four-dimensional block of space-time. In this view, the Big Bang, your first birthday, and the eventual fading of the last star are all happening at once. We just happen to be moving our consciousness through it like a needle on a vinyl record. But even that doesn't fully explain the horror of the quantum paradox. If our observation creates reality, what was happening before there were observers? This is what Wheeler called the participatory universe. He suggested that the universe started as a massive cloud of quantum probabilities. Only when conscious observers evolved did the universe snap into a solid state. But since those observers can look back at the past, they are actually responsible for creating the very conditions that allowed them to evolve in the first place. It's a giant cosmic loop. The universe created us so that we could look at it and, in doing so, create the universe. If that feels like a headache, you're in good company. Even Einstein hated this. He famously asked, "Do you really believe the moon isn't there when you aren't looking at it?" For a long time, the answer was supposed to be a comforting "of course it's there." But the deeper we go into quantum space science, the more the answer looks like we can't be sure. Now, let's look at another layer that makes this even more unsettling: the quantum eraser. Imagine we do the experiment where we measure which slit the particle goes through. But what if we take the information we gathered, the record of which path it took, and we destroy it? What if we erase the information so that it is physically impossible for anyone to ever know which path the particle took? When scientists do this, something miraculous and horrifying happens. The interference pattern reappears. The particle goes back into the past and repairs its wave-like behavior. It's as if the universe is keeping a cosmic ledger of what is known. If the knowledge of the path exists anywhere in the universe, reality is solid. If that knowledge is erased, reality becomes a blur of possibility again. This implies that information, not matter or energy, is the fundamental currency of the cosmos. For space enthusiasts, this has massive implications for things like black holes. We know black holes trap light and matter, but there is a fierce debate about what happens to information. If a particle falls into a black hole, is its information destroyed? If so, does the rest of the universe lose its solidity in some way? This is the information paradox that kept Stephen Hawking busy for decades. If information can be erased or manipulated to change the past, then the entire structure of the universe is much more fragile than we ever imagined. It's like living inside a giant computer simulation, where the code is being updated in real time based on what the players are doing. Is it possible that we are living in a holographic universe? This is a theory that suggests our three-dimensional world is just a projection of information stored on a two-dimensional surface at the edge of the universe. If the quantum paradoxes we are seeing are just glitches in how that information is processed, it would explain why things don't make sense. Scientists are terrified because if this is true, our sense of agency and our understanding of the stars is just a shadow play. We are looking at the shadows on the wall of the cave, while the real physics is taking place somewhere we can't even perceive. Let's talk about the many worlds interpretation of this paradox. Some physicists, trying to avoid the idea of the future changing the past, suggest that every time a quantum decision is made, the universe splits. In one universe, the photon went through the left slit. In another, it went through the right. When you make an observation, you aren't creating reality or changing the past. You are simply finding out which branch of the multiverse you are standing on. In this scenario, there are an infinite number of versions of you, living in an infinite number of timelines where every possible outcome has happened. While this saves the idea of cause and effect, it introduces a new kind of terror. It means that everything that can happen has happened. Every mistake you've made, every tragedy you've sidestepped, is currently playing out in a parallel version of space right next to you, separated by a quantum barrier you can never cross. But even the many worlds theory struggles with the delayed choice experiment. Because even if the universe splits, the measurement still seems to dictate the history of that specific branch. Why does the universe care about what we know? This is the measurement problem. There is no clear line between the quantum world of atoms and the classical world of chairs and planets. At what point does a group of atoms stop being a wave of probability and start being a solid object? If you are made of atoms, and atoms are quantum, why aren't you in a state of superposition? Why can't you be in the kitchen and the living room at the same time? Scientists believe it's because of decoherence, the idea that big objects are constantly being bumped by air molecules and light, which measures them and keeps them solid. But in the vacuum of space, where there is very little to bump into, Quantum effects can persist over vast distances. This leads us to the concept of quantum entanglement, what Einstein called spooky action at a distance. If two particles are entangled, they share a single existence. Change one, and the other changes instantly, even if it's on the other side of the galaxy. When you combine entanglement with the delayed choice experiment, you get the quantum entanglement eraser. You can entangle a pair of photons, send one into a detector, and the other to the edge of the solar system. By measuring the one near you, you instantly determine the state and the history of the one billions of miles away. This proves that space itself is not what we think it is. Distance is an illusion. Time is an illusion. Everything is connected in a web of information that ignores the speed of light. This is why scientists are terrified. If we can't trust space, and we can't trust time, what do we have left? Physics is supposed to be the study of the rules of the game. But what if the rules change depending on whether or not you're looking at the scoreboard? It implies that the universe isn't a thing out there that we are observing. It's a process we are part of. We aren't just spectators in the stands of the great cosmic stadium. We are the players, the referees, and the architects of the stadium itself. Consider the implications for the beginning of time. If we use the logic of the delayed choice experiment on the Big Bang, our modern observations of the cosmic microwave background radiation, the afterglow of the universe's birth, might actually be determining how the Big Bang happened. By pointing our satellites at the edge of the observable universe, we might be reaching back 13.8 billion years and forcing the early universe to take a specific shape. This suggests that the universe didn't just happen and then lead to us. We are currently happening to the beginning of the universe. The past is still under construction, and we are the builders. This level of weirdness has pushed some scientists toward quantum Bayesianism or QBism. This theory suggests that quantum mechanics isn't a description of the world at all. Instead, it's a manual for how an observer should update their expectations. In this view, there is no objective reality. There is only your reality and my reality. And they happen to overlap enough that we can agree on where the door is. But at a deep level, the universe is a purely subjective experience. This would mean that the terror scientists feel is the realization that the quest for a theory of everything is a fool's errand, because there is no single everything to describe. Imagine the vastness of space. When we look at the stars, we are looking into the past. Because light takes time to travel, we see the sun as it was 8 minutes ago, and the nearest star as it was 4 years ago. But if the quantum paradox is correct, that past isn't set in stone. The light from those stars is in a state of wave-like probability, until it hits your retina. You are literally bringing the stars into existence by looking at them. The night sky is a painting that is only being finished the moment your eyes move across the canvas. This also touches on the simulation hypothesis. If the universe behaves like information that can be erased, updated, and influenced by the future, it looks suspiciously like software. In a computer game, the engine only renders the part of the map the player is currently looking at. This saves processing power. Quantum superposition and decoherence look exactly like a cosmic rendering engine. Why bother making the millions of atoms in a rock solid if nobody is looking at them? Just leave them as a wave of probability, a piece of code, until an observer walks by. The delayed choice experiment is like a player trying to outsmart the game engine by looking back quickly, only to find that the engine has already updated the history of the map to stay consistent. This idea is terrifying because it suggests we are not the masters of our fate, but characters in a simulation whose hardware we can never touch. But let's look at a more hopeful yet still mind-bending interpretation. What if this retrocausality is the key to interstellar travel or communicating across the stars? If time can be influenced backward, then maybe we can send information back to our past selves. This is the concept of a tachyon, a hypothetical particle that travels faster than light and moves backward through time. While we haven't found them yet, the math of quantum paradoxes allows for their existence. If we could harness this, we could solve problems before they happen. The universe would get stuck in a logical loop that might just crash the whole system. Scientists are also looking at how this paradox affects the very small. In the world of quantum computing, we are trying to use superposition to solve problems that would take a normal computer billions of years. But every time we try to build these computers, reality tries to break in. The slightest vibration, the stray heat from a cooling fan, acts as an observation and collapses the quantum state. We are in a war with the universe's desire to be solid. To make a quantum computer work, we have to create a bubble of unreality where particles can be in two places at once. We are essentially trying to build a tiny piece of the universe that doesn't follow the rules of the rest of the world. If you find yourself feeling a sense of vertigo, that is the correct response. The brightest minds in history, Bohr, Heisenberg, Feynman, all struggled with this. Feynman famously said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." The terror isn't that we are wrong about the details. The terror is that we are wrong about the nature of reality itself. We think we are solid beings in a solid world, moving through a river of time from a fixed past to an unknown future. But the delayed choice experiment suggests we are more like ghosts in a house where the walls keep moving and the floor hasn't been built yet. As we look up at the vast, dark expanse of the universe, is it a roiling ocean of virtual particles appearing and disappearing, waiting for an observer to give them meaning? When we see the light of a distant galaxy, are we seeing what was, or are we deciding what was? The cosmic scale of this paradox is what makes it so different from any other scientific discovery. When we discovered the Earth wasn't the center of the solar system, it was a blow to our pride. When we discovered the universe was expanding, it was a blow to our sense of stability. But this is a blow to our sense of existence. If the future determines the past, then the concept of free will becomes incredibly complicated. Are you choosing to listen to this right now? Or did a future event necessitate that you hear these words so that the timeline could remain consistent? In a block universe where every moment of time is already written, your feeling of choice is just another part of the script. This isn't just a space science problem, it's a soul problem. It challenges the very idea of what it means to be human. However, there is a beauty in this madness. It suggests that we are much more important than we ever thought. We aren't just tiny specks on a pale blue dot in an indifferent universe. We are the observers who hold the whole thing together. Without the spark of consciousness, the universe might just be an endless, blurry wave of maybe. We are the ones who turn maybe into is. We are the ones who give the stars their glow and the planets their paths. Our curious minds are the force that makes the universe solid. This brings us to the anthropic principle. This is the idea that the laws of physics are perfectly fine-tuned for life, because if they weren't, we wouldn't be here to observe them. But the participatory universe theory takes it a step further. It says the laws of physics are fine-tuned because we tuned them through our observations across time. We are the architects of our own reality, reaching back through the eons to make sure gravity is just strong enough and the speed of light is just fast enough for us to exist. We have created our own cradle. This experiment, this tiny little setup of mirrors and lasers, has opened a door that can never be closed. It has shown us that the universe is not a clockwork machine. It is a living, breathing, interactive experience. The future isn't a destination we are heading toward. It is a collaborator in the present. The past isn't a memory. It's an active project. When scientists say they are terrified by this, they are being honest about the limits of human understanding. We have spent thousands of years building a logic based on before and after. And now, the very particles that make up our bodies are telling us that before and after are just a matter of perspective. It breaks the brain. It makes the solid ground feel like it's made of water. But it also opens up a sense of wonder that is unparalleled in human history. If the universe is truly a participatory, holographic, or informational construct, then the final frontier isn't Mars or the edge of the galaxy. The final frontier is the human mind and its relationship with reality. We are on the verge of a new era of space science where we don't just study gravity and light, but we study the act of knowing itself. We are moving from being students of the universe to being its co-creators. As you look at the stars tonight, remember that photon from the quasar. For billions of years, it flew through the cold, dark silence of space. It saw the rise and fall of galaxies, the birth of stars, and the formation of planets. It was a wave, a ghost, a blur of potential. And then it hit your eye. And in that tiny fraction of a second, billions of years of history were finalized. You made it real. You were the one it was waiting for. The quantum paradox isn't just a puzzle to be solved. It's a message from the universe. It's telling us that we are part of something much bigger, stranger, and more magical than we can possibly imagine. We are entangled with the cosmos in a way that defies time and space, and while that might be terrifying to a scientist trying to find a simple equation, to the rest of us, it is a reminder that we are at the heart of the mystery. The universe is watching us as much as we are watching it, and together, we are creating a reality that is far more wondrous than the sum of its parts. So perhaps the reason scientists are terrified is that they've finally realized that the more we know, the less we know in the traditional sense. We are peeling back the layers of the onion, only to find that the onion is made of thoughts. But in that realization is a new kind of power. A power to look at the future not as something that happens to us, but as something we are currently shaping. And in doing so, we are shaping everything that has ever been. The mystery of the delayed choice experiment remains the greatest ghost in the machine of modern space science. It challenges us to look deeper, to think harder, and to accept that the universe is under no obligation to make sense to our monkey brains. We are the generation that finally looked at the coin and realized it was both heads and tails, and that we were the ones who made it stop spinning. The stars are out there waiting for your next observation. The past is waiting for your next decision, and the future is already here, waiting back to shake your hand. In the grand theater of space and time, the play is still being written, and you are the one holding the pen. Whether it's a simulation, a hologram, or a participatory masterpiece, one thing is certain: it would be nothing without you.